The night sky tells a story of a universe vast beyond imagination. Billions of galaxies stretch across the cosmic horizon, each filled with billions of stars. Yet some scientists now wonder if even this vast universe is not the full story. What if our universe is only one of many? What if countless other universes exist, each with different laws of physics, different histories, and perhaps even different versions of ourselves? In this journey, we will explore what the multiverse means, why scientists take it seriously, and how it could change our understanding of reality itself. The word universe traditionally means everything that exists, all of space, time, matter, and energy. But the multiverse theory suggests that our universe may be just one bubble in a vast cosmic sea. Imagine blowing soap bubbles. Each bubble is separate, yet they all exist within a larger space. In the same way, our universe may be one bubble among many, each with its own space and time. Different theories describe the multiverse in different ways. Some suggest that universes are created through cosmic inflation, a process in which space rapidly expands after the Big Bang. Others arise from the mathematics of quantum mechanics, where every possible outcome might exist in a separate reality. In some versions, the other universes would be similar to ours, with stars, galaxies, and life. In others, the laws of physics themselves would be different, with no familiar matter or energy at all. The multiverse challenges the very definition of reality. If other universes exist, are they part of nature, or are they forever beyond our reach? These questions may seem abstract, but they have profound implications. According to the theory of cosmic inflation, the universe expanded faster than the speed of light in its earliest instant. In less than a trillionth of a second, space itself stretched by an unimaginable factor, smoothing out irregularities and creating the uniform cosmos we see today. But inflation may not have stopped everywhere at once. In some regions, inflation could have ended, forming a universe like ours. In others, inflation may have continued, creating new bubbles of space and time. Each bubble would expand and evolve as its own universe, disconnected from the rest. This process is called eternal inflation. It suggests that universes are still being born, endlessly, in a vast cosmic landscape. Our universe would be just one bubble in this infinite froth. The mathematics of inflation is consistent with observations, such as the cosmic microwave background radiation, the faint afterglow of the Big Bang. While these observations do not prove the multiverse, they hint that inflation is real, and with it, the possibility of countless other universes. If cosmic inflation points to universes on the largest scales, quantum mechanics suggests the same idea at the smallest. In quantum theory, particles exist in multiple states at once, a phenomenon known as superposition. When measured, the particle seems to choose one outcome. But what happens to the other possibilities? One interpretation, known as the many worlds interpretation, proposes that all outcomes happen, but in different universes. If a particle can go left or right, the universe splits into two, one where it goes left and one where it goes right. Applied on larger scales, this means that every quantum event spawns a branching of universes. In one, you decide to take a journey. In another, you stay home. In one, civilizations rise. In another, they never exist. This view is difficult to test, but it flows directly from the mathematics of quantum physics. It eliminates the need for collapse of the wave function, replacing it with an ever-branching tree of realities. For string theory to work, it requires extra dimensions of space beyond the three we see. These hidden dimensions can be shaped in many different ways, like folded origami. Each possible shape gives rise to different physical laws. The number of possible configurations is enormous. Some estimates suggest there could be 10 to the power of 500 possible universes in the string theory landscape. In some, gravity might be stronger. In others, atoms might not form at all. Only a few of these universes would allow stars, planets, and life to exist. This idea connects directly to the multiverse. If inflation creates bubble universes, and string theory provides a menu of possible laws, then each new universe could emerge with its own version of physics. Our universe would be one island in this vast archipelago of possibilities. Though we cannot directly observe these other universes, the mathematics suggests they could be real. String theory thus expands the multiverse from speculation to a potential framework of fundamental physics. The laws of nature in our universe seem finely tuned for life. If gravity were slightly stronger, stars would burn out too quickly. If the strength of the electromagnetic force were different, atoms might not form. If the expansion of the universe were faster, galaxies might never have coalesced. This delicate balance raises a profound question. Why does our universe have the right conditions for life? One explanation is the anthropic principle. It suggests that we observe the universe the way it is because we could not exist in any other. In a multiverse with countless universes, most would be sterile. But at least some would have the right conditions. We live in one of those because we could not live anywhere else. Critics argue that this is not an explanation, but a tautology. Supporters counter that it provides a natural way to understand fine-tuning without invoking unknown principles or supernatural causes. The anthropic principle is controversial, but it gains strength in the context of the multiverse. If infinite universes exist, then life is inevitable somewhere. Our existence would not be a miracle, but a statistical certainty. This idea shifts the question from why is our universe fine-tuned to how many universes exist and what range of laws do they follow. The multiverse is a bold idea, but science requires evidence. Can we ever detect other universes? Some researchers believe we might. If bubble universes formed during inflation, they may have collided in the distant past. Such collisions could leave scars in the cosmic microwave background, the faint afterglow of the Big Bang. Astronomers study this radiation with exquisite detail, searching for unusual patterns that might hint at interactions with other universes. Another possible clue comes from dark energy, the mysterious force driving the accelerated expansion of our universe. The value of dark energy seems strangely small, but non-zero. Some theorists argue this may be explained if our universe is one of many, each with different values. In most universes, dark energy would be too strong for galaxies to form. We live in one of the rare universes where life is possible. Quantum experiments also raise questions. Some interpretations of quantum mechanics naturally lead to the idea of branching worlds. If these interpretations are correct, then the multiverse may be woven into the fabric of physics itself. Direct proof remains elusive. We cannot yet peer beyond our cosmic horizon, but hints and patterns in cosmology, combined with the mathematics of fundamental physics, keep the multiverse theory alive. Despite its allure, many scientists remain cautious. The multiverse, they argue, may not be testable. If other universes are forever beyond our reach, then the idea risks moving from science into philosophy. Critics warn that a theory must make predictions that can be tested, otherwise it cannot be falsified. Some see the multiverse as an escape from deeper questions, explaining fine-tuning by simply multiplying universes without limit. Others argue that invoking the anthropic principle sidesteps the challenge of finding a true physical explanation. Instead of asking why the constants of nature are what they are, it suggests we accept them as random outcomes. There is also the danger of diluting science itself. If every possibility exists somewhere, then how do we make meaningful predictions about our universe? These critiques remind us that the multiverse is still a hypothesis, not a proven fact. It is a framework of ideas at the edge of physics, waiting for evidence that may or may not come. Yet even skeptics acknowledge its value. By pushing the boundaries of thought, the multiverse forces us to confront the limits of science and the nature of reality. If the multiverse is real, it would change our place in existence forever. For centuries, humanity believed Earth was the center of the cosmos. Then we discovered that Earth orbits the Sun. The Sun is one star among billions, and our galaxy is one among trillions. The multiverse would be the next step in this cosmic journey. It would mean that our universe, vast as it is not unique. There could be infinite others, some familiar, some utterly alien. Some may contain life like ours, others may be barren. Some may even host alternate histories, where events unfolded differently. For science, the multiverse could provide answers to questions that have long troubled physicists. It could explain why the constants of nature seem fine-tuned for life. It could unify cosmology with quantum mechanics and string theory. For philosophy and culture, the implications are profound. Are we just one branch in an endless tree of realities? Does the existence of infinite universes diminish our significance, or does it make every moment even more precious? And for the future of humanity, the multiverse offers both mystery and inspiration. Even if we can never reach these other universes, the knowledge that they might exist expands our imagination. It reminds us that reality is greater than we can yet comprehend. The multiverse is not only a scientific theory, it is a call to wonder. The multiverse theory is bold, controversial, and still unproven. Yet it grows from the same spirit that has always driven science: curiosity. From the earliest stargazers to the modern physicists studying the cosmic microwave background, we have always asked what lies beyond. The multiverse is the latest chapter in that ancient story. Whether it is true or not, the journey to explore it pushes us to the edge of knowledge. It forces us to question the meaning of reality itself. Perhaps one day, evidence will confirm that our universe is just one bubble in an infinite sea. Or perhaps we will discover that our cosmos is unique, the only one of its kind. Either way, the search will continue. Because to ask if the multiverse exists is to ask what reality truly is. This is the story of the multiverse, and it is a story humanity has only just begun to tell.